Right, okay, so this is lesson 5 in the 5.3 series, and today we're going to look at something called electrolysis. So if you're using a class notebook, these things should already be in there, but if you're writing it on paper, you need to write these down. Obviously, today's date will be different. There's your title, is electrolysis. What I'd like you to do now is pause the screen and have a go at the questions down here. Okay, so what's a displacement reaction? More reactive. Okay, more reactive metal displaces the less reactive metal. Describe the link between metal extraction and the reactivity series. Okay, the ones at the bottom are easier to extract. Okay, but you can use displacement then to extract certain metals from the reactivity series. Okay, identify the element responsible for the reducing of iron in the blast furnace. Okay, so it's the coke, the source of carbon, but it's actually the carbon monoxide that does it. Okay, define oil rig. Oxidation is loss, reduction is gain. Okay, so like the title suggests in the learning objective, we're going to outline the process of extracting quite reactive metals today. Okay, so we've looked at the ones maybe in the middle now. We know the ones right down the bottom, like gold and all, they're all easy to extract. We've looked at the ones quite close to there then, thinking about just using displacement reactions, so things like copper. We've looked at the blast furnace then to get out iron. And now we want to look at these more reactive ones at the top, which you can't really use displacement for. So we have to use something called electrolysis instead. So, this is what we're going to look at today, okay? Electrolysis happens in ionic liquids, okay? So think about ionic bonding. Ionic bonding is a metal and a non-metal. It's the transfer of electrons. But they have very high melting and boiling points. And the reason for that, and they've got really strong bonds, is because there's a really strong bond between that positive and that negative ion. Okay, so imagine that's your chlorine, that's your sodium, okay, Na plus, Cl minus. There's a really large attraction between that positive and that negative. So what I'd like you to do, using these words by here, can you just have a go at thinking about what you think might happen during the reaction? Okay, so when a soluble ionic compound dissolves in water, the lattice breaks up, okay? The ions separate and are free to move around rapidly. The ions can carry an electrical charge through the solution. The solution can therefore conduct electricity. Okay, so what you need to take away from this, and the really important thing to take away from this, okay, is you have these giant ionic lattices where you've got ionic bonds repeating over and over again. When they are in their solid form, they cannot move. The ions cannot move. So when you dissolve them or melt them, you can dissolve or melt, the ions can then move. Okay, so when you've dissolved or melted them, the ions can move. That means they can carry electricity. So that question comes up an awful lot. When can ionic compounds conduct electricity? When they have dissolved or melted so that the ions are free to move. When they are solid, it does not happen. So why are we talking about electricity? Okay, so electrolysis then is the splitting up of a compound using electricity. So say we've got aluminium and chlorine. We can then use electrolysis to split up the aluminium and the chlorine. Okay, so you get two separate elements then. Instead of it being stuck as a compound, we can then use that aluminium, which you learned about last lesson, doing your research, for planes and cans. Okay, we need that aluminium on its own. You don't use aluminium chloride for these things. Okay, couple of keywords that you might want to note down. The electrode, that's the rod that conducts electricity. So you connect your battery up here, and then they normally graphite rods in them that conduct electricity. They come in pairs. One of them is positive and one of them is negative. Okay, so an electrode is where the electricity comes from, and then you've got your electrolyte. Okay, electrolyte is ionic liquid or solution that can be broken down by electrolysis. So all of this here is a liquid, so it's an ionic compound. Ionic compound, which is in solution now, so it's either been dissolved in water or it's melted, and that means it can be broken down by electricity. So next little thing you need to know, that the negative ions will move towards the positive. So say you've got chlorine minus, it'll move towards your positive electrode, okay? And then your positive ions, such as sodium plus, okay, will move towards your negative electron. You at no point need to remember these charges on your table of ions. At no point do you need to remember them, okay? They will be on the table of ions next to your periodic table, okay, which I've already put in your class notebook. So don't think you have to start learning them, okay? You just need to know the difference between a positive and a negative. Whenever you think about electrolysis, okay, I want you to panic, okay? Nice, easy anagram to remember. So we already got oil rig that we've been using. Oxidation is loss of electrons. Reduction is the gain of electrons. We're now going to move on to another anagram for this topic, and it's called panic, okay? So the positive is the anode. So the anode, because these electrodes are called different things, okay? The positive one is called the anode, and the negative one is called the cathode, okay? Then we just learnt, so this one is negative. Negative is cathode. This one here is positive, okay? And you can already see that you've got the negative ions being attracted to the positive, and you've got the positive ions being attracted to the negative. So you can already see that happening. So first thing I'd like you to do, just thinking about it, so list the products of electrolysis of these molten salts, okay? So I want you to use your table of ions, okay, to work out where each one will go. So I'll do the first one with you. If I looked at my table of ions, potassium would be positive. So it's positive, it's attracted to the cathode, so I'd write potassium here. It's the positive, okay? And then bromide is negative, okay? It will turn back into bromine. Okay, so the next one then, aluminium 3 plus, oxide 2 minus. So the oxygen, which is what the oxide is formed from, will go to the anode, and then the aluminium will go to the cathode. Next one then, barium and iodine. So iodine goes here, and barium goes here. Plus, minus, so sodium is attracted to the negative cathode. Chlorine is attracted to the positive anode. Last one then, calcium, chlorine, fluoride. Okay, so just remember, when it's on its own, it's an N. When it's in a compound, it's a D. So calcium, 2 plus, and then fluorine minus, okay? So that's the first thing, working out what your products are going to be and where they're going to go. Be really careful when you've got oxide, it's oxygen, and when you have got iodine, chlorine, all of that, it's an N, okay? So, there's just the answers there. So what you then have to do is be able to write kind of chemical equations for what's happening. So when you've got lead bromide, you look in your periodic table, lead is 2 plus, bromide's minus, panic down the side. So you've got positive, anode, negative is cathode. And straight away, we should be able to start working some stuff out. So positive, so that's the anode, That's the cathode. Then we know that the lead is positive, so this is going to be the lead. The lead is going to be attracted to the cathode, and the bromide, so the bromine or bromide ions, is going to be attracted to the anode. Okay, so that's to get us started. However, we then have to kind of write chemical equations. So positive lead ions, Bb2+, are attracted to the negative electrode. At the negative electrode, the ions collect electrons from the circuit. Lead ions turn back into lead atoms. Okay, so you've got Pb2+, and it's going to turn back in to Pb. Okay, so it's no longer going to be an ion, it's going to be an atom. Okay, atoms are something without a charge. Their number of protons and neutrons are exactly the same. So what is happening here for it to get that to become an atom from an ion? Okay, all it is doing is it's gaining 2 electrons. Okay, and that is just the symbol there for an electron. Okay, and the reason I know it's gaining 2 is because it's plus 2. So all I do is reverse the charge over and make it into plus 2. So that's the equation that I'd write out. The reason for that is that when it's positive 2, it means it has 2 extra protons. Okay, because it's positive 2, it's got 2 extra protons. So it needs to gain 2 extra electrons to become neutral, which is when it's an atom. Okay, but there's a nice easy way to do it. Plus 2, so it becomes plus 2, and then just the symbol for electrons. And there's just another example there. And it's gaining electrons, so we call it reduction. And then the other side then, at the positive electrode, bromine ions, Br, lose electrons to replace the electrons taken by lead. Bromide ions combine to make bromine gas. Okay, so you've got Br minus, and it needs to become the atom, which is Br. Okay, exactly the same thing then. It's going to lose, because it's -1, lose 1 electron. Just keep that in a box, because that's just the charge for an electron. That's just a symbol for electron. The reason it's negative, negative, negative. Okay, now the problem with this one, and with anything in group 7, plus oxygen and plus nitrogen, is they naturally exist in pairs. So it's 2 Br. So you have to put a 2 in front there and a 2 in front there. Okay, because anything in group 7 naturally exists as a pair. Okay, so what we're going to do So I'm going to have a go at another example with you, and then you guys are going to have a go at a final example. So what I want you to imagine is if you've got your magnesium oxide in here, that's your electrolytes. You've got your electrodes connected by a battery. You've got your negative and your positive. Okay, these are going to be worth 3 or 4 marks explaining what happens during electrolysis. So the first thing I'm going to do, always going to do, is I'm going to write my little anagram as soon as I see an electrolysis question. Positive is anode, negative is cathode. Okay, and I can label them. So I've got my anode and I've got my cathode. Next thing I'm going to do then is turn to my table of ions, and I'm going to get their charges. Okay, so magnesium is 2+, oxide is 2-. So that's the next thing I'm going to do. So what you've got to imagine is you've got magnesium 2+ ions and 2- ions floating around, okay, because they've been broken down, they're in a solution. So the positive is going to be attracted to the negative, and the negative is going to be attracted to the positive. So out of the 4 marks you say you're going to get, you'll get 1 mark for saying magnesium ions, because they are ions, they've got a charge. To the negative cathode. Okay, so that's going to be 1 mark. Okay, might be worth writing because magnesium ions are positive. Okay, and then over here, exactly the same thing for a second mark. Oxide ions are positive because oxygen ions are negative. Okay, so we're up to 2 out of our 4 marks. The next bit then is a little bit hard because we have to write a little ionic equation. So remember, we want to go from our ion form to our atom form where we don't have a charge. Okay, so we want to go from our ion form to our atom form. So to do that here, like I taught you before, you've got 2 plus, so just reverse it. So it'd be plus 2, and then the symbol for electron is E minus, okay? So to get from magnesium 2 plus, you've got to plus 2 electrons, and that will all be happening here at the cathode. And then that becomes just magnesium on its own. Exactly the same over here then. So you want to go from oxide ions to oxygen on its own, okay? Remember, oxygen is diatomic. Whenever you write oxygen, it looks like that. So that means you're going to need 2 of the ions, okay? This is the hard bit then. Just reverse it. So if I was just to reverse it, it would be minus 2E, okay? However, I've now got 2, so I change that to a 4. Okay, that's the hardest bit, remembering which ones are diatomic. That's where your 4 marks are going to come. Okay, another thing they might expect you to add in, is using oxidation is loss, reduction is gain. Okay, so oxidation is loss, reduction is gain. So this is being reduced because it's gaining electrons. And then this one is being oxidized because it's losing electrons. So that's another thing they might expect you to add in. So that's how you push it all the way up to 6 marks if you needed to. So a little bit of a summary. Metal ions are positive and attracted to the negative electrode, where they gain electrons and become an atom again. Metal ions are reduced. Okay. Non-metal. Okay, so non-metal ions are negative and are attracted to the positive electrode. Here they lose electrons and become an atom again. Non-metal ions are oxidized. Okay, so to finish off, I would like you to have a go at these 2, explaining exactly how I did in that example. What would be happening. Imagine they're both 6 markers, so I want 3 bullet points for each side. Okay, so I'm going to give you a couple of helpful hints. I would be thinking panic. I would then be thinking table of ions. And then I would be thinking oil rig. So pause now and tell me what would happen if I put this. Imagine it's already a solution. It's not solid. Tell me what would happen if I put copper oxide into electrolysis, and what would happen if I put potassium chloride into electrolysis. So pause and have a go. Okay, so copper is 2 plus, so positive anode, negative is cathode, so it's going to be attracted to the cathode. Okay, so copper 2 plus is going to want to become an atom, so like we've done before, 2 plus minus. Okay, so it's 2 plus, 2 plus. Okay, just so that's the equation, and then because it's gained electrons, oil rig, reduction is gain, this metal has been reduced. So that's the one side. Then we've got the oxide, which is 2 minus, so that would go to positive anode. So then 2 minus, you want to make it to O. Okay, problem with that is it's O2, so put a 2 in front, so it'll be minus 4 electrons. That's a difficult one. And then oxidation is loss, it's losing, it's a negative sign, so it'd been oxidized. Okay, so that's 6 marks. 6 marks in the bag there. Even if we're just getting the first and the last one right, that would be good. Okay, so potassium is positive, so it's going to go to the cathode. use the anagram because opposites attract. So then we've got K plus. It wants to go to K on its own. It wants to become an atom. So we just do plus an electron. So it's gained an electron. So it's been reduced. And then you've got chloride. So chloride then. Cl minus. So it's going to go to the anode because the anode's positive. Opposites attract. So Cl minus goes to Cl. So what you do is minus an electron. Chlorine is in group 7. So it's 2. So 2. Just be careful of that one. There's a couple like that. Then it has lost electrons because it's a negative, so it's been oxidized. Okay, this is one of the hardest things you'll have to do, but I want you to be thinking, how can we get at least 1 mark? What can we talk about to get at least 1 mark in these? Thank you. Give me an email if you're still really unsure.